Hello and welcome to this vSuite version 0.4 video tutorial, and in this video tutorial I'm going to cover how to do a shadow study analysis with the vSuite. Now if you've been watching any of the previous videos in this series, you'll recognize this little mini urban scape I have, which is the buildings around the main arts faculty at the University of Brighton. And I'm going to do a shadow study, different kinds of shadow study based on this geometric context we have here. So I'm going to need a VI location node to set the location for this shadow study analysis, which can either be EnergyPlus weather file or it can be a manually set latitude and longitude. And we're going to need a shadow study node. So if I go to Add, Analysis Nodes, vSuite Shadow Study, and I connect in my VI location node, that's the node setup I require to do a shadow study analysis. This first option at the top here, ignore sensor. That means that when we set up sensing surfaces for the shadow study analysis, they don't shade themselves, or they don't shade each other. We can set up a geometric parametric animation, or we can just have a static analysis, and I'm just going to keep it as a static analysis for this video. We can set the start and the end day of the year for the simulation. We can set the hourly range within each of those days. So if we were looking at, for example, a commercial environment or commercial context, we might put in here working hours from 8 to 18. Hour steps is how many simulations we do per hour. So that would be 4 simulations per hour. So we get more resolved results the higher this number, but it takes longer to do this simulation. The result point menu controls whether it's the faces of our sensing surfaces or the vertices of our sensing surfaces that will act as the point or points of calculation. So I'm just going to keep that as faces for now. And we have here this little offset number, which basically says how far from the geometric surfaces we specify as sensing surfaces we actually calculate levels of sunshine. And this is useful if you've got non-planar geometry, which is a bit difficult to explain. But in short, if you do a simulation and you get some faces that aren't showing any results or showing obviously wrong results, it can be worth increasing this number a little bit. So that's the options within a node, and that node is kind of ready to go. But we do need sensing surfaces. The shadow study analysis is the first of the analyses we'll cover where we need to specify where within the scene we're actually going to calculate our chosen metric. So there are various ways that we can do that. And the first way is a common way where we create our own sensing geometry. So I've just created a plane. I'm going to rotate it slightly, scale it slightly, so it just fills up this courtyard within the model. Put it down near the ground, and just try and make sure that none of the buildings overlap it, although they could. But for the purposes of this exercise, I just want to kind of fill that courtyard with a sensing surface. Now, if I press Tab and go into Edit mode, and I have faces selected down here, we can see I've only got one face within this object, within this plane. And I do my calculation at the faces of my sensing planes. So I'd only calculate one result currently. So I want a few more results really. So I'm going to press W, pick subdivide, and then I'm going to subdivide that surface, and I might give it 19 subdivisions. So that's now 20 by 20. So I'll now get a result and a calculation for the center of each of these faces. And one thing I'll do while I'm here is I will check that my normals face in the right direction. Normals in 3D graphics define which way a face is facing. and we want the normals to face in the direction that we're going to be sensing from. So we're going to be sensing from above, and so we want our normals pointing upwards, and that's what we've got, so that's fine. If we found that they were pointing downwards, or they were pointing in the wrong direction, we could press W again and select flip normals. And every selected face will then flip its normal the other way. But we want them pointing upwards. So that looks fine. So the vSuite knows, well, the vSuite doesn't know yet. We're going to tell the vSuite in a moment. But this is a geometry that the vSuite will eventually know is our sensing geometry for our shadow study analysis. To tell the vSuite this is sensing surface, sensing geometry, we need to give it a certain kind of material. So if I come over here to the Material tab, I can, if I've newly created this geometry, there'll be no materials associated with this geometry. So I can press plus here, and that will allocate a material slot to this whole object. And I can now put within this material slot a material. Now I created this sense material earlier. What I might do is I might just create a completely new material, call that sensor, and for the vSuite to know that this sensor material is a sensing surface, down here in my vSuite Material tab, I need to change geometry to light sensor. So now the vSuite knows that this geometry and the faces within this geometry with this material attached are going to be the points of calculation for our simulation. So that's fine. So now that I've got that sensing surface set up, I can now press calculate, and that finished fairly quickly. I want to show you something later on, but I will need, there we go. A new feature in version 0.4 of the vSuite is this window that will pop up whenever you do a simulation that's going to take maybe a significant amount of time. This window will pop up and it will tell you eventually, it will give you an estimate of how long the simulation will take, and it also offers a cancel button so you can cancel the simulation if you want. That cancellation might take a while because the vSuite only checks periodically whether it should carry on or whether it should be cancelled. On OS X, that window does not appear above Blender's window. I don't know why. It's fine on Linux and Windows. So once you press calculation, the Blender window will lock up, and then you might have to move the window out of the way to see your progress window. But that's now completed. So in my vSuite display tab, which is in my 3D view properties panel, which I can open up with this little plus sign up here, I've now got this option to display the shadow study results. I'm going to turn off VI 3D display for the moment, it's not important, and press display. And now we can see the results plotted onto that sensing surface. What you might notice when you press shadow display or any other kind of geometric display is that you don't initially get the coloration. And what you might need to do is to change this legend color option, which we can use to change the coloration of that sensing surface. I quite like hot for shadow study analyses. So we've now got some options for this sensing surface, and we've got some options in a 3D display. Another new feature of version 0.4 are these icons that will display within a 3D view when there are some metrics to display. So this icon here, for example, let me just expand this window. This icon here is a legend icon, and that allows me to bring up a legend that relates the coloration of the plane to, in this case, the percentage of time that that portion of the plane was in sunshine. So I did a study for the whole of the year. So these white points, for example, over the whole of the year, for all the times that the sun is above the horizon, they receive direct sunshine about 25% of the time. I've also got this, and I should say that legend also updates with the change in the legend color. Although you might just have to bring your mouse over to the legend to get it to update. For this object, excuse me, we also have the ability now to bring up a scatter graph. And that scatter graph will show us for the selected object. So if I could click another object, that I actually did a simulation with the buildings before. So they're showing up a different set of metrics. But in general, for the actively selected object, which has results associated with it, we get this scatter graph which shows the percentage of the overall object's area that is in sunshine for all the days of the year and all the hours of the day. And all these display elements which are brought up by these icons, they can be clicked and dragged and made bigger and smaller, etc., or expanded and collapsed and moved around. So we can see that this plane gets maximum levels of sunshine at around 2 o'clock in the afternoon, but nothing after about 4 o'clock and nothing before about 10 o'clock in the morning because of the shading from the buildings around it. We have some options over here to change the maximum range in color, not only of the coloration of the plane, but also of the legend. Because I've got relatively few calculation points, I can click and drag on this legend max menu item, but in general, it's better to click on it and enter a number, especially when you've got lots of calculation surfaces, because it can get very slow otherwise. We can do the same with the minimum. We can choose to plot either logarithmic or linear. Logarithmic is good where we have a very big difference between the highest and lowest values in a plane. But because we're only talking about sort of 0 to 25 in this case, then linear is fine. Legend color we've covered. For the selected sensing object, we can turn on wireframe mode and turn it off again. We can just use that to compartmentalize the different elements of the sensing plane if we want. We can also change the transparency, so if we want to expose some geometry behind our sensing plane, we can. And we can also do numerical point visualization. So if we turn on enable, and if I increase my font size a little bit, we can see now we get a numeric display of the percentage of time that each particular point was in sunshine. So minimum, about 11% of the time these points here were in sunshine, and maximum just over 25. We can also choose to display those numbers only on a selected object. So because this object is now not selected, we don't see the numbers, but we'll see them when we select it again. And we can also pick visible only. So if I've got that turned off, I see those numbers wherever I navigate within my scene, even if I have to look through, or I'm looking through another object. If I click visible only, and I just update my view, I'll only see the numbers that I can actually see. So that can be useful for clearing up the 3D view display. Turn those off. Font size, font color, font shadow, all relates to the numerical display of those point numbers. And if some numbers don't appear, this position offset value can again be useful. And in general, should be set to the same value as the offset value within the shadow study node. So I just turn that off. When I finish visualizing results within the scene, I should always declick my display active option, and that will turn off my 3D view display elements and turn off my point numeric display. So I'm going to get rid of that sensing plane now. And that's a very common way of specifying your own geometry, your own custom geometry to act as a sensing surface within the scene. But we can also select any geometry, any existing geometry within the scene. So for example, if I pick the ground plane, which has already been subdivided into, in this case, many little triangles, I can now once again associate with that ground plane my sensing geometry, my sensing material, sorry. So this is my main material for this ground plane, and I'm going to change that default material into my sensor material. So now the vSuite knows that this whole ground plane for each face within this ground plane is now a sensing point. Now there are loads more sensing points now than there were in the initial analysis. So for the purposes of speed, I'm not going to do a whole year. I'm just going to do the first 10 days of the year. So 1st of January to the 10th of January. And I'm only going to do 2 simulations per hour. But I can now press calculate again. And we should now see, again behind our Blender window, our calculating window, and this is going to take roughly a minute or so to complete. So I usually try and think of something to say while the simulation is simulating, but I can't right now. So I might just sit here in silence until the simulation is complete. And 3, there we go. So now when I press shadow display, and again this takes a little bit longer because we've got loads more sensing points, the whole ground plane is now, or does now contain that shadow study data. So positive Y is north in the vSuite, so we can see there's no shadow here to the south of the buildings, and they generally cast their shadows to the north. Legend display once again, scatter display. We've only done a simulation for the first 10 days of the year, but this data now represents the percentage of this whole ground surface area that is in sunshine for each of the days and each of the hours. So that can be very useful for ground plane analysis. And all these other options remain the same as they did before. I'm just going to show you one more sort of nice kind of sensing surface that you can set up. If I now again turn off display, you will notice that this sensing surface is a new surface. Oh, I've hit the wrong one. This sensing surface is a new surface. It's a new object, actually. And like any object in Blender, you can do anything to it. By default, it gets created just above the original geometry. Now, why was I talking about this? I've forgotten. Oh, yeah, just to say, the original geometry, which was my ground plane, is called TQ3OSW0 blah blah. This result plane is called the same name, but it's just got res appended to it. So it's these res objects that have been created as part of the display process. So make sure these are selected when you want to delete those sensing planes. So the original object, I'm going to go back to my default material, so it's no longer considered to be a calculation surface. And now I'm going to pick a part of my urban scene to be a simulation surface. So if I now go into edit mode for this urban scene, the urban geometry, now you can see I've done this before, I'm going to get rid of that. I can now select individual faces of this geometry, and by applying a sensing material, I can make them calculation surfaces as well. So I'm just going to select. I'm just using circle select. I'm not trying to do this for any actual analysis purposes, just for the demonstration that I've now selected those particular faces. I can add a new material slot to this material. I can assign this material slot to these selected faces by pressing the assign button. And now I can put my sensor geometry within that slot, that sensor surface within that slot. So that sensor material has now been applied only to those faces. So if I tab out of edit mode, and now I can probably do a whole year's worth of analysis again because I've only got relatively few faces. Press calculate. And that hopefully shouldn't take too long. Was that number of sensing points? It can be that the simulation can finish before the V-Suite has had a chance to tell this window how much longer it has left to simulate. And that might be the case in this particular example. But hopefully this won't take too long. Yeah, there we go. So now I press shadow display. And now I can see that shadow study surface, all those shadow results are purely on that part of the building that I specified the sensing material for. So you could do this for the whole urban scene. It would take a long time, but you could apply that sensing material to the whole of the urban geometry to get a completely navigable and interactive sort of display of the shadow and percentage of sunshine for within the model. One thing I will do, just because we've got a relatively small number of sensing points, I will turn on VI 3D display just to show you what it does. So with that turned on, when I've pressed the display button, I now get this extra option 3D level, and I can now extrude my results out. Point visualization, same as before. Again, it can be slow to manipulate this dialog interactively, so sometimes it's just best to click and enter a number. Again, the scatter now is purely for this portion of the building that we've designated the sensing material for. So those are the three those are the sort of main ways that we can specify sensing geometry for our shadow study analysis, which is a very similar process to specifying sensing surfaces for our analyses with Radiance using LiVi, which I'll cover in a subsequent tutorial. But I think for now that's everything I need to say. Okay, thanks for watching.